Okay, so our next presentation is Grant Dasher from Google. Oh, there you guys. I was panicking, Grant. I didn't see you. So you are here. Very good. So one of the interesting things about Google's work with security keys is that they've actually quantified the very tangible value they found from deploying security keys inside of Google as an enterprise. So Grant's going to tell you all about that.
Hello, everyone. Let's see here. How's everyone doing this morning? Ready for yet another session? Okay. So I'm Grant. I'm an engineer at Google. I lead one of our internal enterprise identity teams. So my focus is on trying to solve identity problems that our enterprise customers using G Suite or our cloud platform have. But this talk is actually about our own internal efforts to deploy security keys as our tool for strong authentication. So I think probably many of the people in the room know the story here. In 2009, Google was, our corporate infrastructure we had an intrusion from actors associated with the Chinese. And I think that was really a wake-up call for us. For a long time, we had a good security team, obviously, but we were starting to increasingly get into the business of storing more sensitive, like more and more user data. More and more users were putting their photos or their videos or their email on the cloud, and it was clear that the storing user data in the cloud was a way of the future, and it was essential for Google's business. And the wake-up call was, hey, we have this asymmetric threat from sophisticated nation-state actors, APT-level actors. And our corporate infrastructure was not up to the challenge of dealing with that kind of actor. At the time, we were just in the process of planning on deploying OTPs. The rollout was sort of in the early testing stages, and it became quickly obvious that if we wanted to be able to defend against state-sponsored actors, Google was a big, powerful company at that point, but it was becoming increasingly bigger and more powerful. And it was clear that we needed to step up our game. And so we started this project to design the security key, which eventually became the FIDO U2F standard. And the basic goal was a recognition that passwords are broken. And I think this recognition over the next 8 years has been borne out, not just Chinese-level actors attacking Google, but Russian-level actors attacking American organizations, North Korean actors attacking Sony, and even personal high-value individuals, people like John Podesta, getting their email hacked, or Colin Powell, even though it's protected by SMS OTP. So the fundamental problem with passwords is that they can be phished, they can be reused, and they can be keylogged. So let's go through these one by one. So password reuse is obviously where this started, right? If you reuse your password and you store it, say in a website that gets hacked, if they hack the passwords, if it's stored in clear text, or if it's stored in an unsalted form, or even if it's stored in a salted form, you can often reverse engineer the raw password and then parlay that to log into that same user's other accounts because they're reusing passwords across those accounts. So that's a problem. But more than that, you can phish the password, right? Everyone knows about phishing. You just pop up a website, you pretend to be the other website, you get the password. And they can be keylogged, right? If you get onto that user's machine, you can just sort of collect their passwords. In fact, more than 2/3 of security incidents in 2015 involved phishing with a 23% effectiveness rate. The key point here is that OTPs help against shared passwords, but not against phishing. I think this is a sort of a common misconception. When people put up graphs and they say, look, if you deploy multi-factor authentication, your phishing drops. That's true, right? But the reason it's true is mostly because the attackers just didn't try to capture, especially in the consumer space, didn't try and capture the alternate login page that you go through when you have, an SMS OTP multi-factor authentication flow, or even a hard OTP factor, right? And so we don't so you can sort of interactively phish a user, and we saw this happen, in 2016 for the first time, targeted attacks at individuals. So, where they got phished via this mechanism. And so I think that was sort of validated our assumption that, we really needed to move beyond SMS OTP and get to strong authentication like a security key, like a FIDO U2F credential. Is phishing effective? So yes, it's very effective. Even the most obviously scammy phishing pages, about 3% of users will go through. And at scale, that can get you access to a lot of credit card numbers. But with super well-designed phishing pages, the kinds that these ATP level actors will use, 45% of the time they get through to their target, which is remarkably effective. OTPs, like we said, have a lot of problems. One is they're still phishable in the way that I described. You have this sort of keychain of OTP fobs that pick up, right? That, if you have 5 banks and they all have 5 different RSA tokens, you sort of accumulate a nice keychain. You can have one U2F token that spans all of those through the schemes that were talked about before. Of course, SMS, increasingly issues around cost and availability have limited the deployability of SMS. And finally, and perhaps surprisingly, not surprisingly that users find it hard, but users find these OTP codes, difficult and annoying to use. And I have some data about that in a second. So the security key is focused on solving this authentication problem. We think it works for both enterprise and consumer use cases. Derek talked a little bit about consumer use cases with Facebook a second ago. I'm going to focus on the enterprise side of this. It's unphishable, and also, if you combine it with something like the IETF token binding standard, it's unman-in-the-middleable. In other words, it can be used to detect the presence of an active proxy, even if they have compromised the PKI. So if they have, issued a certificate that your host trusts via some scheme, by getting some CA in the web's root cert to issue them a bogus certificate, you can detect that using a security key if you couple it with token binding. So that's another property that it has. And of course, it's also compact and scalable, right? You can put an infinite number of websites on one of those tokens. So the operation of these guys is pretty simple, right? So you sign in with your username and password, you just insert the token and press a button, right? So I carry one on my keychain, you just plug it into the laptop, press the button, pretty easy. It's based on asymmetric cryptography, right? Standard public key cryptography. Usually we give this talk in isolation, so I think I'm going to tell you this probably for the 3rd or 4th time today, if you've been here for all these sessions. But basically, each time, the reason why we say it's privacy preserving is that each time you go to a separate relying party, we mint a new key pair and give the user the public key to store. And then, of course, that server provides the key handle to the device, which allows us to derive the private key and verify the signature via the challenge response mechanism that Derek talked about. This enables a bring your own device methodology. There is attestation built into there, so in an enterprise context, if you want to require, say, that the device has certain hardware properties, you can trust the vendor's assertion of that. So there is an attestation protocol built into the registration to allow you to sort of attest to properties of the device, but you can also sort of allow people to bring your own devices. So at Google, we use the attestation mechanism to require that people only use the keys that we, as Google, issue to them, which have certain special properties that we think are important from an enterprise security point of view. But on the consumer side, we just accept any key out there because we think it's better than a password, right? If we raise the bar too high, then we hurt the deployability of it. That's our belief. So now the interesting part of this. So what was our experience deploying this? So on the enterprise side, we require the use of security keys for Google employees. We use our own G Suite product, so the vast majority of sign-ins at Google are through Google's IDP. There's an internal corporate IDP as well, which handles some other use cases, but that's also integrated with the U2F tokens. We also use it for SSH, and it forms the basis for all authentication at Google. On the consumer side, it's an opt-in for consumer customers, and it's been adopted by other relying parties as well. So this is really the interesting slide. So on two metrics, we think that we have really improved the usability of second factor authentication with the security key. The first is the amount of time it takes users to authenticate. In fact, with the old OTPs, a friend of mine created a little OTP bingo game, which because people didn't like typing in their OTPs, right? They would look at their OTP token on their phone or whatever, and they would type in the code, and it was so painful that in order to make it enjoyable, someone wrote a Chrome extension that counted the number of repeat numbers in the OTP, and sort of it was like OTP poker. You could get 4 of a kind, right? If you had an OTP that had 4 4s in it. So that was sort of the way we made OTPs fun and interesting, but no one liked them, right? They were painful, they were annoying. You had to take your phone out. We tried all sorts of things. You put your phone in your pocket, you tap it. We used Bluetooth to send the OTP code, all sorts of stuff, but none of it really worked super well. We cut the time to authenticate in half by deploying the security keys, and then on the consumer side. This is a little different because the populations of users are different, but on the consumer side, you can also see that users who are using security keys get a more secure authentication a lot faster than a one-time OTP code. So we think from a usability point of view and a security point of view, these things were beneficial. Right, so if you're not paying attention, the point is that they're faster. This one is actually even more compelling to me. So you can see that support incidents. So with OTPs, you can see that we had we don't have a scale on the left side because I don't want to give you exact scale numbers because it tells you things about like the number of people at Google in various capacities, not all of which is public. But the point is we cut the number of support incidents substantially. So you can see that when everyone was using OTPs, we had a high level of support incidents. And then if you look in the bottom right corner, when essentially everyone was using security keys, you can see a low level of support incidents. So it's really rather remarkable. I mean, we cut them by like 90% from the time where we finished the security key deployment here versus where we were at when we were 100% on OTP. So you can see as the number of security key users goes up, the level of support incidents doesn't really increase, but we drastically reduce them. So we really cut our support volume. It's a way of reducing support costs pretty substantially. Again. There's ongoing work. So we've recently deployed mobile-friendly protocols. So you can get these tokens from Phishing, which have BLE in them. There's other vendors out there who also offer BLE tokens that can be used for talking to a mobile device. And in fact, I think in a very soon version of Android that's rolling out now, you will be able to get mobile access to your security key via BLE. You can already do it via NFC today. The Yubico tokens that everyone knows and loves, the fancier ones support NFC protocols. With the web authentication working group that's been talked about previously by Tony, more browsers, Firefox, Edge, others are picking up support for the protocol. More platforms, Windows, Android. In the future, hopefully iOS and OS X will pick up support, although certainly if you're using Chrome on Mac OS or on iOS, if you're using the BLE tokens, you can also talk to that. And then, of course, the FIDO 2 work that's been talked about, right, is the natural extension of U2F. And sort of pushes it towards more use cases around biometric and using your phone as a security key and those kinds of things. So how do you get started? So you can use U2F internally in your enterprise. If you're using G Suite, for example, we have features in G Suite that let you enforce for certain sets of users the use of security keys. So you can get this property of being very hard to phish by enforcing security key users by your employees. You can also use use it for service provider authentication. So if you're in the banking industry, for example, and you're a counterparty to a large number of banks, you get them to deploy U2F, you can have 1 token instead of 10 RSA keys. And then, of course, for external customer authentication, high-value customers, these are like the people whose emails really are sensitive, right? We would like them, and in fact, many of them do use security keys today as a way as protecting against phishing attacks. So, you can turn it on with Google pretty easily. You can also use it with Dropbox, GitHub, Facebook. And then we've got released a bunch of reference code. We've got a reference implementation of a server. We've got a little Python library if you want to integrate it into a command line application. Yubico has a nice list of libraries that also talks about a number of different third-party open source libraries that people have written. So questions? Yes, sir.
Can you address the recovery incident response procedures when you lose a device?
Sure. So what we do at Google to minimize that is we typically give people 2 of them. There's a one that's left in their laptop for sort of ongoing re-authentication events that we make them do when their sessions expire. And then there's the one that they keep on their keychain. When someone loses all of their keys, they go to their admin. So inside of our admin panel in G Suite is a way of essentially issuing tokens on behalf of a user in your domain. So you can have some sort of admin provisioning flow. And so we typically have them show up in person, verify their identity, and then manually by scanning their employee badge or whatever, and then they type in their password and we register them a key, something like that. So you can set up whatever flow you want. But I think the one advantage of these guys is you can have a couple of them, and I have like 5 corporate security keys in various different machines of mine, and so the chance of me losing all of them is basically 0. But yeah, if you do lose all of them, that's the recovery strategy that we employ.
Well, even if you lose one, don't you have a blacklist of the keys so it's not used by somebody else?
Right. So you can do that. It depends on the way in which it's lost. So yes, like we do revoke them, right? When someone loses them, you revoke the key that was lost. You can name it in the server so you know which one it is. Yes, it's also in concert with the password. So like if you don't revoke it, it's not the end of the world because it's not clear. It's unclear. It's like a key. It's unclear whose account it belongs to, so it's not clear how valuable it is depending on the context. But yes, we do revoke them.
Time for one more.
Jeremy.
So this is a question passing on from somebody back in DC who responded to the tweet I showed about the help desk, which is they asked, is that only for Google employees or is this also what you've dealt with for consumers? And I know you guys haven't done a consumer case study yet, but wondering if you're gathering similar data and might be contemplating putting something out in terms of where it's been making things easier.
Right.
Beyond just the speed, but also for help desk or support calls that you get.
Right. So I don't have any data on the consumer side for support reduction. I will say that second factor, like hard second factor account recovery is one of the most challenging account recovery problems that we face on the consumer side. And we're sort of continuing to work through that. I think the way we think about it is if you're a high value actor, we should make it very difficult for you to recover your account, and we can pay a relatively significant manual tax for those sort of limited set of high value users. And if you're a sort of more traditional user who's still using a security key, our standard practice is multiple keys, and then and that cuts a lot of the problems, and then have a sort of a very long and involved recovery process that we try as much as possible to avoid being socially engineered. But yeah, no, we haven't released any data on that.